Okay, now we're going to practice using the tool, the Punnett square, to predict what the likelihood of two parents having an offspring with a specific trait. The first one we're going to look at is laboratory mice. And laboratory mice can either be gray or they can be albino. The gray coat is dominant over the albino coat, and we use a capital G for the dominant allele and a lowercase g for the recessive allele. So in this case, we're crossing a female who is heterozygous, and remember, heterozygous means it has one dominant trait, one recessive trait. And we have a male who is homozygous, which means he has the same trait, but this time it's homozygous for recessive. And it doesn't matter if you put the female traits here or you put the female traits here. So we're going to put the mom. Let's see, let's get that centered. There we go. And let's change the color so we can see them separate. Okay. So the mom has a big G, a dominant allele, and she has a recessive allele. And then the father has two recessive alleles. Okay. And this is just like when we did meiosis. Remember, we have to split the chromosomes. So during fertilization, when they rejoin, we have the proper number of chromosomes. So they are eggs and sperm are haploid. So when they join, they'll be diploid. Okay, and then it's kind of like a battle game of Battleship. So for this each of these four boxes represent offspring. And so since this is representing sexual reproduction, mom gives an allele and dad gives an allele. Okay. And the same here, you go straight down. So the mom gives an allele and the dad gives an allele. Oops. There we go. Okay, then we come over here, and mom can only give these two offspring the recessive allele. Oops. And it doesn't matter, a little small there, who you put first. I'm just doing the color coding so that you can see that an offspring is receiving genetic material from both parents. Okay, I'll paste that there. Make it a little bigger. Okay, so now we've finished the cross. And remember, Punnett squares are just the probability or likelihood that an offspring would get a certain trait. It does not mean if these two mice had 4 babies that 2 would be this and 2 would be that. So each child has a whole new probability. So if we look at this, if we look at the phenotype, and phenotype is the actual physical trait that you can see. And so anything with that dominant allele, the capital G, will be gray. And so we have 2 of the 4 with the dominant allele. So that means 50%. There's a probability that 50% chance that their offspring or the baby mice will be gray. And then there's also a 50% chance, 2 out of 4, that the mice will be albino. So that's the probability for phenotype. If we look at genotype, there's 3 types of genotypes. You have homozygous for the dominant trait, heterozygous, and that should be little g. And then you have homozygous for the recessive trait. So we have 0% of having a homozygous dominant trait mouse. We have a 50% chance of having a heterozygous and a 50% chance of having a homozygous recessive. Now, sometimes you'll be asked to find the ratio. And so we have a 2-to-2 ratio, where the ratio 2 gray to 2 albino. We also have a 2, I can type this here, a 2 heterozygous to a 2 homozygous for the recessive trait, for the genotype. So that's how you use a Punnett square. Punnett squares are to find the probability that when crossing two sets during fertilization, what is the probability of a certain trait showing? Now it's your turn.